Imagine a world where lost or damaged teeth can be regrown, not with artificial materials, but with your own living tissue. Tooth regeneration is an emerging field in biomedical science that is shifting the landscape of dentistry. Instead of relying on crowns, bridges, or implants, scientists are now exploring ways to regrow natural teeth using a patient's own stem cells. This approach promises teeth that look, feel, and function just like the originals, with the ability to sense pain and adapt over time. Let's explore how this revolutionary idea is becoming a reality. Traditional dentistry has long focused on artificial restoration using metals, ceramics, or plastics to replace missing teeth. Tooth regeneration, however, marks a significant shift toward biological restoration. This means that instead of inserting foreign materials, dentists could one day help patients regrow their own teeth. These regenerated teeth would be living, capable of responding to the environment and even repairing themselves. The potential benefits are enormous, from improved oral health to a more natural look and feel. To understand tooth regeneration, it's important to know how teeth naturally develop. This process begins as early as the 3rd week of embryonic life. It's a complex dance between two types of tissues, the ectoderm and the underlying ectomesenchyme. Together, they guide the tooth through several stages: initiation, bud, cap, and bell, each with its own unique changes. These stages are orchestrated by intricate signaling pathways that ensure the right shape, size, and structure for each tooth. The formation of a tooth is guided by several key signaling pathways. Proteins like BMPs, FGFs, SHH, and WNTs act as messengers, telling cells when to divide, where to move, and what to become. These signals are crucial for shaping the tooth's crown, forming its roots, and ensuring that each tooth develops in the right place. Without these pathways, teeth would not form properly, highlighting the importance of precise biological communication in tooth development. Stem cells are the body's master builders, capable of transforming into many different cell types. In adults, these cells help maintain tissues by replacing damaged or old cells. Dental tissues are a particularly rich source of stem cells, making them ideal for regenerative therapies. By harnessing these cells, scientists hope to trigger the body's natural healing processes to regrow teeth and supporting structures. One important type of dental stem cell is the dental pulp stem cell, or DPSC. Found inside the soft tissue at the center of the tooth, DPSCs are capable of forming dentin and pulp, as well as other mesenchymal tissues. Their versatility makes them a promising tool for regenerating not just teeth, but also bone and other oral structures. Research continues to uncover new ways to use DPSCs in dental medicine. Beyond DPSCs, there are other valuable stem cells in dental tissues. Dental follicle stem cells are useful for regenerating the tissues that support teeth, such as the periodontal ligament and bone. Periodontal ligament stem cells themselves can become fibroblasts, cementoblasts, or osteoblasts, cells that are essential for healthy gums and bone. Together, these stem cells provide a toolkit for rebuilding the entire tooth support system. One strategy for tooth regeneration uses scaffolds, three-dimensional, porous materials that act as a framework for new tissue growth. These scaffolds can be made from natural polymers like collagen or chitosan, or from synthetic materials such as PLA and PLGA. Bioceramics are also used for their compatibility with bone. The scaffold provides spatial cues, supports cell attachment, and allows nutrients to flow, all of which are essential for building new, healthy tissue. Scaffold-free tissue engineering takes a different route. Instead of using an artificial framework, this method relies on self-assembling cell constructs like cell sheets, spheroids, and tissue strands. These constructs preserve the natural interactions between cells and their surrounding matrix, which can be critical for proper tissue function. By mimicking the body's own organization, scaffold-free approaches may offer more natural results in tooth regeneration. While the dream of regrowing whole teeth is still on the horizon, tooth regeneration is already making an impact in the clinic. Current applications focus on repairing specific tissues, such as the pulp and dentin or the periodontal ligament and bone. These advances are helping patients avoid more invasive procedures and preserve more of their natural tooth structure. One of the most promising clinical uses of tooth regeneration is pulp-dentin regeneration. This technique replaces traditional root canal therapy by restoring the living pulp and dentin inside the tooth. The result is a tooth that remains vital, with the potential for continued growth and repair. This approach could revolutionize how dentists treat deep cavities and tooth injuries. Periodontal regeneration aims to rebuild the supporting structures of the teeth, such as the gums, ligament, and bone. This is especially important for patients with periodontal disease, which can lead to tooth loss if untreated. By regrowing these tissues, dentists can help patients keep their natural teeth longer and improve overall oral health. The ultimate goal in this field is to regenerate entire, fully functional teeth. While this remains a vision for the future, research is rapidly advancing. Scientists are exploring organoid technology miniature, lab-grown versions of organs and protein inhibition strategies to guide the growth of complex tooth structures. These breakthroughs could one day make it possible to replace lost teeth with new, living ones that are indistinguishable from the originals. Despite remarkable progress, several challenges remain. Scientists must learn how to precisely control the growth and integration of new teeth, ensure long-term safety, and make these treatments affordable and accessible. Ongoing research into stem cell biology, biomaterials, and tissue engineering is paving the way for future breakthroughs. The hope is that, one day, tooth regeneration will become a routine part of dental care. Tooth regeneration represents a bold new frontier in dental medicine. By harnessing the power of stem cells and advanced biomaterials, scientists are moving closer to a future where lost teeth can be replaced with living, functional ones. This shift from artificial to biological restoration could transform oral health for millions, offering hope for natural smiles and healthier lives.